All right, so you've had a chance to think a little bit about what the gravitational field is. I'm going to share some knowledge that I am able to learn about the gravitational field by sort of looking at this equation and interrogating it. First of all, I'm going to look at the units of this expression. So if I look over here, for example, I know the units for force should be newtons, which of course I also know should be kilogram meters per second squared. And then if I go over here, I see that we have kilograms for the mass, which means everything that's left must have units of meters per second squared, which is a little bit interesting because those are units that we might recognize as acceleration units. So we might start connecting up this quantity, little g, with other acceleration-like quantities that we've seen. Another thing that we can look at is the fact that both sides of this equation are vectors, which means the gravitational field is a vector quantity. So it will have both a magnitude and a direction. The other thing that you can look at, again, I've tried to label these things carefully, but the gravitational field in this instant is something that is created by an object with mass that will then act a gravitational force on another object with mass. Again, my sort of little example might be that a planet might create a gravitational field. This would be object B that the tennis ball feels a gravitational force due to as object A. We, in this class, are going to start by using the Newtonian model for the gravitational field, which says that little g can be written as a constant big G times the mass of the object that's creating the gravitational field divided by r squared, where r here is the distance between the center of the object that's creating the gravitational field and the location where you are finding the gravitational field. So as an example, right, again, if I have my planet creating a gravitational field, this r would be the distance from the center of that planet to the center of the object that is feeling the force by that gravitational field. And then this is a vector, so I need to add in a direction. And I'm going to label that direction as minus r hat. And this really is just a fancy way of identifying that the gravitational force is an attractive one. The minus sign here is indicating that the gravitational field will point towards the center of the object that is making the field. All right, like I said, this capital G here is a constant. It's actually a universal constant. It's about 6.7 times 10 to the negative 11 in SI units. You can go ahead and look up what those units are if you want, or if you pay attention to this equation here, you can actually figure out what they are on your own. But this is fundamentally what the gravitational field is in the Newtonian model. In particular, right, we want to know what thing is creating the gravitational field. So if you add a label like this on here, right, it is the mass of the object which is creating the gravitational field. In this case, that would be object B.